All right, for those of you who have joined me early, I'm going to start streaming everything very soon. If you see me looking to the side, it's because, of course, I have two monitors set up, so that way I can see everybody. I can see you chatting along with me, so I may turn my face to the right or left if you see my face at all. What I'm also going to be doing over the course of the next 2 to 3 hours, depending on how long this takes, and again, this doesn't normally take the whole 3 hours, but we'll see if we can get in a break at around 10 minutes to 12 as normal. All right, so give everyone a bio break and so on. After this stream is done, and again, this is kind of a pre-stream, we haven't really started yet. What I'll be doing is I'll be encoding it. I'm not sure if I'll be producing a transcript or whether I'll be adding closed captioning for those people who need that. Okay, but this time all we're going to be doing is we're going to be waiting for the group of people to join us. Again, usually we start 10:02, so keeping traditionally, what we're going to be doing is we're going to be waiting for everyone to join. So I see a couple of users here. I'm just going to say hi to them as well. And I'm just going to type over here at the monitor as I do that. So I've got another little monitor going on. And let's see if I can actually add in some chat myself. And looks like it's a wonderful day in the neighborhood. All right. Hey there. All right, I figured it out finally. All right, so for those of you who see me, that's cool. Again, right now I'm seeing a couple of guests that are online. So again, bear with me, guys or girls, whoever you are, as we continue to wait for everyone to join us in about 6 minutes. Okay. And again, if you have any questions, you can use the chat panel on your screen there to ask the questions as we go. So that way, and I'll try and look there periodically so I can stop and answer some of the questions. I'll repeat your questions online so as to ensure that everyone gets the same kind of questions out there for the recording. Because even though everyone can see the questions as we're chatting here on Ustream, on the recording itself, you won't notice the questions popping up at all, right? Because again, what we're doing is we're doing it live here, and I'm going to record this stream for later broadcasts. And again, I'm not sure if I'll be broadcasting this on Ustream for those of you who are just coming in, or I mean uploading it to Ustream if I can, or if I'm going to be uploading it via YouTube. My gut feeling tells me YouTube is going to be the way to go, but we'll see how that goes. Okay, so again, waiting a few more minutes as we continue. So I'm just going to address some more of the questions over here as I turn my attention to some of the people who have just come in. And again, I see only a couple of users here that have joined. So let's see how it goes. So I'm just going to ask some questions here in terms of, hey, have you guys started assignment 2 yet? So there we go. Let's see if that they started assignment 2. And again, I'm kind of typing and talking at the same time, which is kind of redundant, but again, it's for the benefit of the recorded video. All right, so I'm going to see what they've said here as we go. So again, a boring video as we're starting off here. So for those of you who are watching the video instead of the broadcast, you probably can skip ahead until the 11 o'clock mark, which is going to be about 10 minutes into the video. How do I go about restarting? For exit, you make the loop false. Okay, you have to specify. Try to be more specific. So that was the question that came up for me. Restarting what? Okay, as we're getting closer. Still looks like we only have a couple of users, so that's good. That means there's only going to be a couple of people that are going to take me off kilter here this morning. And eventually, what I'm going to do is I'm going to pop over and turn off my the video here on the top right corner of your screen, so of me, and then focus on the actual application. And so I'm going to continue to talk as we go with the restart button. Okay, I see what you're asking. So you're saying, how do I go about restarting for exit? You make the loop false. So again, for the restart button, that's a good question. So the user here online is asking about the restart button. How do we go about restarting? And when I say restart, really what I mean is reset the application so that the variables are reset and the screen shows or I guess the application, sorry, not the screen, the application, the app gives the user his starting money again. So again, I guess the questions are really around assignment number 2, and if I asked for a restart button around assignment number 2, and the question is, well, how do I restart the app? Well, I'm not asking you to restart the app. I'm asking you to reset your application parameters so that way the user sees that his money's back up. Okay, so that's for assignment number 2. We're going to talk a little bit about assignment number 2. We're also going to talk a little bit about assignment number 1 and some of the stuff I've started marking already. I'm about a quarter of the way through. Okay, another couple minutes and then we'll see if more people are going to join us, and then I'll begin. Okay, still only have a couple of users. Let's see how it goes. So otherwise, I know some of you are busy, and that's why I'm kind of doing a combination of a video broadcast, like I'm doing here live on Ustream, thanks to people at Ustream, and I'm also doing a recording, like I said, and it's going to be either through YouTube or via Ustream itself. Now, I'm not recording to Ustream at the same time because I need to do some video editing, kind of post-video production. And the only reason for that, of course, is because I want to be able to add a transcript, so for people who want to be able to see what we're talking about as opposed to hear what we're talking about. So for those of you who are there and you can hear and see me, that's great, but there's going to be the option of looking at a transcript as well. Okay, we see, again, there's only a couple users on, and we're at 11 o'clock, so I'm going to start off. And so for those of you who will be joining me later, I'm going to periodically look over here at the chat just to make sure that I cover some of the questions that come up. So try and stop me if you can, and like I said, I'll look over at chat and see if I can try and pause as we go. Okay, so I'm going to turn off the video now, and I'm going to go right into the app. All right, so welcome to lesson 4. I think this is the beginning of our official broadcast. Again, we're broadcasting today as opposed to meeting tomorrow during our regular scheduled times. So we have 2 times we typically meet at. One of the times is around between 10 and 1, and the other one is between 2 and 5. So those are the kinds of time frames we usually go with. And again, we have section 1 and section 2. Both sections are invited to go to both times. But for today, what we're doing is we're kind of doing this video broadcast because the regular scheduled class isn't going to happen on Thursday. Okay, so we're talking about Python again, and I think my question to everybody, people who are here with me, users who are with me watching the video live, I've asked them how assignment number 2 is going. Some of them are just asking some questions at this point. But I have to make some comments about assignment number 1. So I've looked at assignment number 1. I'm about 25% through the marking at this point, and I'm going to continue to try and mark so that way within about a week more I'll have everything marked up. It looks like most of you are doing very well. I'm happy with the majority of what you guys have put together. There are some people, of course, giving me the bare minimum, as some people do, and that's fine. I mean, it's really the learning is all around what you put into it is what you get out of it, kind of thing, right? So, you know, for me, I think you know, I've seen some of the students' assignments. It looks like there is a lot of people who are getting over 100% because of the bonus, right? And I think that's great because that's going to arm you up for what's going to happen as we move towards more difficult assignments where you're not going to get 100% because there's some really challenging stuff coming up. For example, the next assignment number 2, is going to be using Tkinter. And Tkinter is something that we're going to talk about. Now, again, if you don't want to use Tkinter, I'm going to say this again for assignment number 2, you can also use Pygame or even PyQt. Now, I'm not going to cover PyQt in this course, only because we have a limited time frame. We only have 14 lessons. This is lesson 4 of the 14, right? So I'm going to try and cover a bit of Tkinter this week and a bit more next week. Now, this week I'm going to try and talk about an intro to Tkinter, so you can look at some of the graphics requirements that are going to be required for next week. I'm also going to cover a little bit more of that next week on Thursday when we meet. So that's why I've kind of moved off the date from a completion perspective until Friday. And again, as we move forward, that may change. I'm going to make sure that everyone is successful. The slot machine game, even though I've got everything online and you can read some of the lessons online, a lot of that takes some careful planning when it comes to you know, reading ahead. Some of you aren't good at independent study and so on. And there goes the ad. Oh, by the way, you will see some ads happen through the Ustream, the live stuff. But for the video itself, there are no ads. That's the advantage of watching the video afterwards, right? But for the people who aren't professional Ustream guys, I'm going to kind of pause. When I see the video come up on my screen, this is what I'm seeing right now. I'm seeing a video come up. I'm going to pause and then go back as we continue to stream live. Okay, so let's see if this video is going to end at some point. Looks like it says the ad will end in 25 seconds. And 23, 22, we're still counting down. So I'm just going to wait a little longer so that way the people online have a chance to to view this as well. I'll probably edit this section out if I can, only because for those people who aren't seeing things, again, there's a bit of a pause for the ad. Okay, and we're back. There we go. So I see the ad is back. We're back to live streaming again, and I apologize about the ads for those of you who are online, but I can see it here because I'm looking at the kind of a second monitor here, a second access. I can see who's online. So I see about 5 users now. So welcome to those people who have joined me lately. Again, if you have any questions, you can use the chat. I encourage you guys to do that. I think it's important that we have some as much interaction as possible here. Okay. Back to the lesson. You didn't see an ad. That's good. Someone says, I didn't see an ad. Well, some people are going to see an ad. Some will. I'll answer, and some won't. If you're streaming this, if you're actually taking the stream in through an app, and again, you can actually view this through one of your iPhone, iPad apps, Android as well. Ustream has an app for those platforms. Then there's going to be an option for you to view the ad or not. So you may or may not see the ad come up. Okay, but I'm going to pause as we go. So bear with me again. This isn't a perfect stream, and again, this is the trouble with going live. Okay, so again, we talked a little bit about assignment number 1 and how I saw that it was pretty good. Most of the people got really good so far, and again, I'm up to about D for marking. What's going to happen is over the course of the next assignment, I'm probably going to start from the bottom up and probably do like from a Z back to A, and that way people can see their marks kind of fairly, right? And you're going to see it come up online. So you're going to see your marks come up online over the next several days. Okay, so let's talk about again, we're back to Python. Okay, we're about lesson 4 now. Right, so I'm going to maximize the screen here, and I'm going to shift back and forth between our lesson and Aptana. Okay, so really, what are we talking about today? We're going to talk about the need for a graphic toolkit, right? And the graphic toolkit that we're going to be using primarily in this course, aside from Tkinter, is Pygame. Okay. Again, we're going to talk about different frameworks to understand how to structure our games, our programs when we create games with Pygame, and that's really what the alter and the idea frameworks are. Okay, so most programs, like it just says right here, they run more slowly than the underlying computer. True, that is a very true statement. Computers these days are lickety-split, they're fast. In my day, they were really slow. Computers were like hectically slow. And so the program would run even slower than that. So you can imagine the type of delay that we would get when it comes to the kind of video feedback that we'd have. So, and I showed you guys in class last week some of those ROMs that we were doing in class that actually looked like the old arcade games. And the old arcade games basically showed us like there were some simple graphics and some sprites and everything else. Nowadays, as we move forward, the graphic capabilities of processors have improved, and so you're going to see that our computers are pretty robust systems, and we can run as much into the video and all that as we go forward. Okay, so let's take a look here. So there's something we got to talk about in terms of frame rate, and I kind of talked to you guys about this when we were discussing our final project. I said, hey, don't make your game run faster, because some people are thinking, hey, if I want to do my look at my assignment instructions for the final kind of shows that I have 3 levels that I got to do. If I was a student, I've got to do start screen and an end screen, and one of the requirements is, hey, add more difficulty. Well, the difficulty can be in terms of definitely of levels, so you can actually have more than one level. And some of you said, well, how come I can't just make my game faster? Well, really, faster is not a great option. Actually, it's not a great practice in general. Faster might work well in certain platforms, but faster, and I mean, but what I mean by faster is actually changing the frame rate, the speed, like it says here, at which the visual display updates, is great for a computer, but really bad for mobile, right? So we're going to talk about this, and what we want to try and do is we want to have a consistent frame rate. A frame rate that's going to be 30 frames per second is probably around right for most platforms. For example, the iPhone or even Android, 30 frames per second, you're going to be hard pressed to get that. So frame rate is the speed at which the visual display updates, how many frames we see, for the human eye to kind of detect over the space of a second. And again, our persistence of vision, and you might hear this as a term going forward when it comes to animation and so on, the persistence of vision that we're going to have for a human, 30 frames looks like there's animation going on, right? As we move slower, we do a slower frame rate, and what ends up happening is we can detect more of a choppiness to movement across the screen. So again, 30 frames is probably our goal in terms of what our frame rate is going to be. Okay. And again, I'm talking to everybody here as if you don't know some of these terms, like for example, what a pixel is and so on, right? Well, each time you look at different pixels on the screen, right? We have a dot on the screen would be actually a pixel, like it says here. Different resolutions, 640 by 480 and 800 by 600, are great for the monitor or a desktop application, but for example, for mobile, it's 320 by 480 or some other resolution, right? So again, I invite you to think about those types of resolutions as we move into the mobile space. And you're going to see me talk more about mobile as we go forward, because mobile is really the way of the future. Okay, so I encourage you, when you make your final product for your project number 1 or 1A or 1B, to think about a mobile resolution, right? And that way, what you can do is you can convert your application into mobile a lot easier. And I like what it says here. Games often use custom user interfaces. Of course they do. And in Pygame, we're going to definitely make our custom user interface. You're going to see, for example, in Tkinter, we're going to make a user interface with some built-in classes and functions that Tkinter has. As we talk later on today, we're going to talk about Tkinter. They're built into the libraries that come with Tkinter. But when it comes to Pygame, you've got to kind of create your own buttons and your own interface. So there's the challenge, and as we move forward, and we're going to talk more and more about Pygame over the next several weeks, you're going to see the customization that you're going to do as you create your own your game framework. So we talked about this a couple of times about the game loop and what that is, and really, it's really a structure that allows us to continue to display our graphics and keep the user in a particular interface loop, if you will, as an example, by almost like creating this while loop. And we talked about actually while loops last week. We talked about having a sentinel variable, and the sentinel variable was something like keep going is equal to true. We talked about that as well. So you're going to see that there's going to be in our game loop, and this is specific for Pygame, by the way. Other structures may not require this type of game loop. But actually, once you start the window in Tkinter, you'll notice that you're in a loop of some sort, and you have to kind of kick yourself out of the loop or stop Tkinter for it to stop displaying the window. But for Pygame, once you break out of your game loop, then what happens is your screen stops to update. So like it says here, so the game loop itself begins with initialization. It starts off when you set up your computer to display the game. Then what you do is you continue to display this loop, and you terminate the loop when you decide through a button or some other user interface element, or even when the game is lost, as an example. And typically we don't exit the game when the game is lost. We actually go to another screen. But you can, if the game is lost, exit the program. Okay, so we have to create that exit scenario, if you will, and that's part of what this game loop is all about. Okay, so again, we have to, like it says here, we have to set up game resources for our game. We've got to have some two-dimensional images, and not in this particular course, but in other ones. Like for example, when you join Rui, the other instructor, as you move into 3D graphics, and you're going to be probably using Blender or Flash, you might have 3D models that you're going to be using. You're going to have a set of background images in this game for sure, especially for this slot machine game, where you're going to need a background image for your slot machine that's going to hang out in the background that makes it look like a slot machine. Now, sound effects, I really haven't asked for sound effects in this next assignment number 2, but if you do add them in, you figure it out on your own. You can look at Pygame, and I encourage you to look ahead to the Pygame resources that I've given you. If you look ahead and you see how to generate sounds, and you put them into your game, you're going to get a bonus. So again, these are all the different resources and others, of course, that you're going to have to kind of put together when you're creating your own game. Okay. And again, it says here resources are usually created in specialized authoring tools, and I think some of them, for example, when it comes to graphic resources, I like to use Fireworks for when I modify graphics. Some people like to use GIMP or Photoshop or other kinds of tools. And again, GIMP would be the open source tool out there if you want to modify your graphics. For sounds, there's all kinds of open source tools for sound editing. Or if you're someone who likes to use professional sound editing programs, that's also an option. But what you do is you create all these sound effects, and of course you edit them and so on, the 2D images and so on. You modify everything to make sure that they work for your game before your game is created. Sometimes what it says here is we construct a game from the beginning with this placeholder data, almost like a block, like you might have a sprite that really doesn't have any kind of image at all. It's just a block, right? But what we want to see is the sprite move around and do some of the things that we want our game to do, right? And so that's why we create this placeholder as we're building our game. Because our game isn't going to be built in one blow. It's going to be built over several stages. We're going to start off with, like I told you last week, we talked about how we're going to start off building the game by creating almost the back end, the engine to the game itself, almost in a console. We're going to get some console output first. And then what the next stage most often is to take some of that back end and convert it into a GUI. That's also something that we can do as we move forward into our game construction. And then, of course, the third stage would actually be to kind of take those placeholder images and convert them into real sprites and to respond to user input. So as we move forward, we're going to talk about stages of how we create our game. Okay. And I like what it says here in terms of game entities. We talked about this actually in other courses when we did Advanced Java. Some of you who were with me in Advanced Java, we actually did programming in with Android, and we talked about these game entities as being made up of objects. I'm going to pause here for a second as I see the ad is running on the side. So for those of you who don't see the ad, that's cool. I definitely see the ad on my side, which means for those of you who aren't professional users of Ustream, you're going to see there's going to be an ad generated every few minutes, and that's fine. Like I said before, what I'm probably going to be doing, and another ad. There's a couple ads. There we go. A couple of 30-second ads, almost for a minute. Wow, that's crazy. As I said before, the video itself will be, I'll try and edit out the ads if I can. If not, then you'll hear me talking just like this, and that's fine too. So, again, I'm just going to check as I'm going to take an opportunity here to check some of your questions if you have any. And I see still there's about 4 users that are online. Okay, here we're back. I see that we're back online now, and there's no ads. Okay, so let's talk about these game entities. We're talking about objects, and again, going back to our presentation here, objects that are usually created, and like it says here at the beginning of the program. So, for example, I might preload all my images as objects, sprites, if you will. And what I'm going to be doing is I'm going to load all these objects up and then manipulate these objects, these game entities, as we move into game creation. Now for Tkinter, this doesn't really apply. It's not the same as Pygame. So again, this stuff that I'm talking about now primarily applies to Pygame and other kinds of frameworks like this. For example, Cocos 2D, which is a very popular open source framework for game design, as well as others. And again, like we talked about in the other slide, the gameplay itself occurs inside this almost endless loop until we give it an exit condition. Okay. So I like what it says here as well. We talked about this actually earlier. I mentioned this. Python games don't run at 30 frames per second because that's a happy speed for Python games to run at. Right? And again, it's going to be, you can run it slower, and again, you might see some more choppiness because persistence of vision, human persistence of vision will pick it up. We'll be able to see that there's some choppiness between one image and the next. Okay. We have to have games interact with the user, right? So, otherwise, if the user's just watching the game go, right, like it just says here, it's just like watching a piece of animation or a movie, right? So there's got to be some kind of input. Now, typically, there's input from the mouse, the joystick, the keyboard, or other devices. We're not going to really focus on joystick because, really, from a joystick perspective, there's some special things we have to program with the device, and not a lot of us have joysticks that we can use. Not everyone does, right? And typically these days, especially from a mobile perspective, and I want to think about mobile, clicks with the mouse work as touches with from a finger, right? When it comes to an iPad or some kind of tablet design, or even when it comes to a phone or other mobile device. So they work pretty well. The phone or the mobile device interprets clicks as presses. So I think it's safe to say that we can, for this course anyway, not think about controlling joysticks And again, that's going to reduce, or paddles or other input devices. It's going to reduce some of our choices, but it's going to make it so that we're more directed. So again, when you make your game, please focus the game on mouse and keyboard clicks. And even mouse clicks might be the best thing, so we can avoid some of the complications that come into translating a game if you ever do translate it into iOS or Android. Okay, so again, we get input from these devices, and then what we have to do when we write our code is we're going to have to figure out what the intention is when we click on different objects that we see on the screen. So we're gonna be listening. We're going to create event listeners for some of these objects that we're going to be creating, and we're going to see that as well in Tkinter when we create bindings for some of these controls that we're going to put up online. Okay. So again, part of our game loop is to update some of these game entities, right? An example of this would be you have a sprite and you want to move it from one part of the screen to another. Well, even though we're giving it the command to move, you're only going to see it move at 30 frames per second. So the faster you move an object, for example, if you move it at 5 pixels per frame, you're going to see it jump a lot faster than if it was moving at 1 pixel per frame, which is really, really slow. So these objects inside the game loop, they're going to update according to our frame rate variables. Okay. Other things are, for example, we might create other objects that your entities will collide with. An example of that would be something like you have an avatar, the player's ship or other character or so on, and it might collide with a bullet, right? A bullet sprite, or some kind of other object that exists on the player's screen, right? So these collisions that we're going to talk about create almost like a death scenario where you might have another sprite generated as a result of the collision. We're also going to talk about boundary collisions as we move forward and what that means. The screen itself, when you look at the screen, has these boundaries, right? We see the screen as, sometimes we can see it as boundless, where we can actually move from one part of the screen to the other, and it'll reflect. It'll look like we teleport from the left side, and also our avatar appears on the right. But in most scenarios, our screen is limited so that the character's avatar or even some of the enemies won't be allowed outside of the screen, especially when it comes to a top-down scrolling design. Now, if it's a free-scrolling design, there are no bounds. What's going to happen is if you fire a bullet outside of the boundary, it's just going to keep going, right? So it might strike something, it may not, right? Or you may make it so that when it exits the boundaries, that the bullet disappears, right? But there might be other things that are outside the boundaries of the viewable screen area that exist from a programmatical view, if you will, where we've coded other elements that are outside of the view screen. And what's going to happen is as they enter our viewable area, or our point of view, if you will, the stage that we're going to talk about in a second, we can interact with them. Or otherwise, when they're outside of the stage, we can't interact with them. So what is this stage anyway? And what I mean, I'm just going to switch back here so I can show you kind of with my hands, because I don't have the blackboard to show you with, so I'm going to just quickly zoom in here. So the stage is really an area that's, let's say the viewable area of the screen, right? So once I move outside of the screen, I mean, you can picture it really like a piece of paper, right? So here's my stage, my viewable area of the screen. If I move outside of the screen, or to the bottom or to one side or the other, what ends up happening is the viewable area is. Sorry, I've got a question. I'm going to fly there in a second. The viewable area is only the stage. There might be other elements out here, outside of the stage area, that exist, right? But the only element that we care about is the element on the stage itself. And we're going to talk about things that are on and off the stage. Okay, I'm going to switch back to our view now. So bear with me as I switch off my my face. Okay. So that's really what the stage means. We have boundary collisions that are either at the boundaries of the stage, or we have elements that are outside of the stage area that we're going to be dealing with, and we're going to be dealing with them programmatically. We're going to plan for these elements outside of the stage area if there are any. Okay. So again, what it says here is really true. Real change is done on invisible variables. So we might have, for example, variables like score. We might have variables like player health and so on. All that stuff is being updated at the frame rate of the game, right? So the faster the frame rate, the more these updates happen, the more the game will chug, if you have a lot of variables to update. Okay, I'm going to go here and answer one of the questions here as we move on. One of our guests here is saying, do we all hit ads at different times? I'm watching one now. And then another Ustreamer says, yeah, we do see them at different times. So again, I apologize for the ads as I'm using the free version of Ustream. And I'll say try and bear with me. If I can type. All right. Okay, so let's go on to the next step. We talked about this. Actually, we talked about refreshing the screen. And again, the visual display, and what it says here is really, really right on, right? Is the primary output to the user, right? So, I mean, you're going to see the visual display. You're going to hear audio as well, and it's not really covered here. But basically, like it says here, we're going to create images for every frame, right? A new image. So what we're going to do, we're going to wipe the screen as we move from one frame to the next. We're going to wipe the screen and recreate it. We're going to kind of throw this this frame back out there. So every frame, we're going to wipe the screen and throw images back onto the screen. We're going to update the screen all at once in its entirety, and that's part of the stuff that we're going to be doing. And again, what it says here is we may decide to erase or partially erase the previous position for each of the entities, right? We're going to draw the entity in its new state, right? For example, if I move a sprite from one corner of my screen to the other, maybe what I'm doing is as the player is changing positions of the sprite, he's also changing the angle of how the sprite is going to look. And so I have to change the state of the sprite as well. Right? And the state might go in, if I get killed, that's another option as well. Let's say, for example, I have an enemy sprite that collides with me. I might, my player sprite might go dim for a few minutes, or a few seconds, I mean, while we're able to get back into gameplay, give the player a chance to get back in without being killed from different bullets that have been flying all over the place. So you see that in some of the older arcade games. So states may change every time the frame is updated. Every time there's a new frame, we're going to do a lot more updating. And like I said, if you have a lot of these external variables going on at the same time, there's going to be a lot of updating that we're going to have to do. Okay, so let's talk about some of these APIs. Now, some of this stuff, DirectX, OpenGL, and SDL, you may or may not have heard of. These are these application programming interfaces that you can tap into with our code here. So Python allows us really to type into both OpenGL and SDL. There are DirectX APIs for Python as well, but we're not going to handle those. And we're not going to really talk about OpenGL in this course. Again, that's really for the next course. So the one we're going to be dealing with is SDL, okay, which is our open source 2D API that we're going to be using for Pygame to Kinter and any other framework you're going to be using. Okay, and again, what it says here, it's free, it's powerful. There's all kinds of stuff that you can do with it. It's written in C, so it runs pretty quickly, right? And Pygame is really a Python wrapper for this SDL, right? And that, which is really the platform for us to do two-dimensional gaming. Okay. We talked about Pygame already, and I'm not going to go over this too much. And again, when I created this PowerPoint pack, we were at Python 2.7.4, and I haven't changed it since. Right now, we're at 2.7.5 because it just recently updated. But more or less, it's not very much different. Pygame 1.9.1 and 1.9.2 are so similar, and those are the ones that we're going to be generating. We're going to be using for our code. Okay, looks like there's another ad. So for those of you who are watching with me and there's another ad, we're going to have to wait a little longer as the ad is kind of displaying up here. And this is why, like I told you before, I'm probably going to put it up on YouTube because of the ads that are generated for on Ustream. Okay, so just bear with me as this first ad finishes, and then it's going to start the second ad, which is another 30 seconds. And here we go with the second ad. Okay, and I'll check and see if everyone's doing okay. See, again, as I'm looking here at the chat, I'm looking at that there's 4 of us now. It looks like 1 person dropped off, and that's okay. I understand how challenging this is to look at. At the same time, I'm going a little bit slower than I would normally go when we're dealing with the class because typically I'm going to go pretty quick. So I can't get as much human interaction. Okay, the ad's off now. Can't get as much human interaction as I can when we're in person. So this is the disadvantage of doing kind of this remote session. So again, try and bear with me as best as you can. Okay. So again, we talked about installing Pygame. We've already done that. And here's some primary features of Pygame, and it's going to list it off for you. We're talking about the display mechanism, which is the screen, our surface object, which are our images, right? And what I mean by that is the surface objects we're going to be talking about, and you're going to see them. Each of these things are part of the classes that we're going to be using. The rect objects are really shapes or sprites, if you will. The input modules, and we're only going to be using the keyboard and mouse, right? Our output modules are going to be images and audio, because we're going to have audio with all of our games as we move out of assignment number 2. And there's also some utility modules we're going to be using, which are time and transformations to transform some of our images that we see. For example, making something double the size, or shrinking it to give it that look of it moving farther into from a perspective view, if you want, if you will. Okay, so those are the kind of things we're going to be doing with some of these modules in Pygame. And again, on that, going back to Tkinter, we're going to be using a lot of Tkinter modules when it comes to creating our game, the slot machine game, as we go forward. But again, I'm going to say this one more time. You don't have to use Tkinter. I'm going to show you a way to use Tkinter to generate quick interfaces for assignment number 2. But you may also decide that you want to use Pygame for assignment number 2, which is perfectly acceptable. Okay, just a little more challenging actually. So now we come into this framework idea. So we're creating games, all right, and if we start from scratch and we start creating as we go, we're going to run into a little bit of a problem. Just like we did before, maybe you've seen this in other classes when we talk about pseudocode, right? We really want to create almost like a framework for creating our game. Okay, so why a framework? Well, it is easy to remember, right? When we talk about there's 2 different frameworks we're going to be using: the idea framework, again when we're creating our games, and the alter framework, right? Which is really the main move part. Okay, so let's take a look at some of these 2 frameworks. So here's the idea framework. So really at the beginning, what we're going to do, we're going to import and initialize Pygame. We might import and initialize Tkinter as well, right? That works in both frameworks, whether we're using Tkinter or whether you're using Pygame or Cocoa Studio or whatever. Importing and initializing the modules are going to be the same. Okay. Then we're going to actually create the display configuration. So how big is my window? Is it going to be 640 by 480? Is my window going to be 320 by 480? As an example, if we're going to be on a mobile platform, or is it 1024 by 768? How big is my window, my display configuration? I'm going to load up my entities. I'm going to define my sprites, or I might, from a Tkinter perspective, load up the images for my buttons or for my background or so on. I'm going to create these things, right? And then what we're going to talk about is we're going to go to the action part of our framework. And the action part of our framework is the second part, the alter part. So let's move to that one. Actually, here's the idea code, and this is a great example here of what it says for Pygame. So we're talking about Pygame here. So we're going to import Pygame. That's part of the imported initialize stage. And here's the pygame.init. Init would be the method that we're going to be using to initialize the Pygame framework. And then what we're going to do a couple things here. We're going to say Our screen, and I like interposing screen and window, right, which is the top level window that we're going to be creating here. Our window is equal to going to be equal to, I'm going to assign it, the output from this next module, this next method, which is pygame.display.set_mode. That's how we're going to do it. That's the method that we're going to be using. And it's 640 by 480. So we're saying we're going to create a screen that's 640 by 480. That's what this line really means. Pygame.display set caption is actually going to set the title bar of the window in Python to say hello world. Okay, and then here's our entities. Right, we're going to have our background, which we're going to create a surface for our background. Right, and the surface is almost like a frame that we're going to kind of put on. It's going to be it's another area on the inside our top level window that we're going to define colors and so on. Okay. And our background, we're going to use this convert method to convert the background into something that's viewable from a Pygame perspective. We're also going to fill it with what looks like, and if you look at RGB, what would be B? Looks like a blue background, right? And really, then after that, we're going to take action. That part is going to be broken into alter steps. So let's go to this. I'm going to switch back now to this idea.py program that we've kind of got in our from an Aptana Studio perspective. So I'm going to switch over to Aptana Studio. Here we are. And here we are in Aptana now, and I'm going to go into lesson number 4. And again, I've kind of linked all my lesson archives into these linked folders underneath my Intro to Graphics project that I've created for Python. Now again, some of you had issues with this for assignment number 1. You had problems because you forgot to add in this project that you have to kind of create, and this is where you kind of define your Python interpreter and so on. But going back, so let's take a look at lesson 4. So we're moving down in here, and we're going to look at the idea.py program. So we're double clicking on it. It's going to come up in our Aptana Studio here as my computer chugs along. And as it does, I'm going to kind of look to the side here to see if anyone's chatting with me or not, which is cool. So here it is. And the guy who wrote the previous book, Andy Harris, right, he's the author of this stuff. He's put in this doc string up here to let you know he did it. And again, when we do our I review assignment number 1 with you, and I will do that next class. I'll go over the next class. I'm hoping to have everything marked. But I'm going to talk about what I really like and I didn't like about some of the stuff that you guys put in here into the header of your code. Okay, let's take a look. So part of the idea, the I in idea, is import and initialize, right? So we're going to import Pygame here, and here we define a main game loop. Okay, remember, here's our if name is equal to main down here at the bottom of our screen, if name is equal to main, and which basically tells us that, hey, if our main function exists, then execute it. That's what this thing does, right? If it doesn't exist, well, do nothing, right? But really, what we use this framework for, when we define a main function and when we define this this line of code right here, if name is equal to main, it allows us that if we create other functions that are inside this code, I'm just reviewing, it allows us to to use this code itself as a library. And we'll talk about that as we go forward. Okay, so we've imported it here. If you notice, I'm importing it outside of my function. This is almost like a global import. Oh, when I hear global, by the way, I get the heebie-jeebies because, you know, I'm thinking about some of the issues with global variables that I've seen for assignment number 1. And to me, you know, global variables are, like for most programmers, bad practice. You want to try and avoid them, especially as you're moving into this more object-oriented world, right? When you want to use objects, you want to try and avoid using global variables as much as possible to maintain that encapsulation, the encapsulation portion of our object-oriented programming. But anyways, this is a global import, and this is okay. This is kind of like our meta code right here that allows us to import the Pygame library. Now, if Pygame has been installed properly in your system, this won't error out. If it hasn't been installed properly, this is going to give you an error here. You might see an error mark that comes up on your Aptana screen, or if you're using idle, you might see a problem when you're trying to run this thing. Okay, so if you've installed Pygame properly, you've adjusted the environment variables so that they work, you won't see an error here at all. And as you run things, you're going to see that as you move forward into when we run this thing, it's not going to error out. If you have installed properly, you're going to see tracebacks that come up saying, "Hey, what's Pygame? We don't know what that is." But once you've imported this thing, you're going to see now another little line of code here, Pygame init, right? Which is basically initializing the Pygame window. These two things you need to initialize. Okay, now we're going to go to the display portion of the IDEA framework, the D in the IDEA framework. It's a screen here, but again, I could simply just change the name of this variable, remember, and again, Python is loosely typed, so screen is a variable we're just creating right now, right, just on the fly, and right now we're creating a variable, an instance of this Pygame class. That's what we're doing here. That's what this screen is. Screen is actually, or if you want to call it window, is an instance of this Pygame class with a display set to 640 by 480. Okay, that's what this thing is doing. And then here what I'm doing, I'm actually displaying the caption, hello world, like I said. So this is part of our D, our display configuration part of our IDEA framework. Now we come down to the E, entities. We're just defining a background, which is just part of the Pygame framework. And we're saying, hey, I want my surface to be equal to the screen size, because I can actually use screen.getSize to say, I want the background to be equal to the size of my screen. This doesn't always have to be true. I can create multiple surfaces or multiple backgrounds that I kind of display on the background for Pygame. So I can have surface A and surface B, and they can touch, but they are different surfaces that I use to display different objects in the background. And then what I do is I use this convert method, and if I hover over it, for example, if I want to know what this convert method does, or it says, let's take a look at, it says it's not found actually, or it's found at module 9 in the Python path. But if you actually look at the convert method, we're going to talk about how to kind of debug and look at what this surface means. Here's what it says. It says surface convert found at Pygame surface, and what it does is it talks about the depth, and I haven't put that on right now, and any kind of masks that we have, which I haven't really kind of defined right now. And masks are almost like surface objects that overlay other objects. So right now we're just going to use the default constructor for it, which is the empty constructor. And again, we're going back to object-oriented programs. So that we have to convert the surface into something that's viewable. And now we're going to use the fill method, right, to fill the surface that we've created, which is we've defined as a background, with a color. And now there's different options for the fill. And if I hover over it again, it's going to tell me I can have a color, I can assign a sprite, I can just define special flags, I can do all kinds of stuff here. Right now all I'm doing is defining a color. The background is the surface color is blue. Okay? So that's the one thing that we're doing. Now we're going to get into the action part in a second. But this is the idea part. See I, D, E, and A. And this is where the action or the A part starts going on. We're going to talk about the alter steps. Now if I run this code for a second, and I'm just going to run it here in Python, right, you're going to see a blue background. Right, that's all it does. Right, so you're going to see a blue background running over here. Okay, I see another ad that's coming up, so I'm just going to pause for the ad, and I'm going to look over at some of the questions you have. And we're almost time for a bit of a break, a little bit of a bio break. In about 4 minutes, I'm going to kind of pause for a break as I leave this window up and going. For those of you who've been following me for the last 45. Okay. And we're almost on the first ad, and here comes the second ad. And usually the first ad, the second ad on Ustream, for whatever reason, looks like the exact same ad, right? So it looks like there's not a lot of people paying for ads. This looks like a Bell ad, which is kind of cool. At least on my end. You might see different ads on your end. Who knows? So again, we're talking about Pygame here. We're going to be working as well with Tkinter as we move forward. And right now we're just pausing for the ad. Okay, we're back. So we've got this hello world window that pops up. So here's our window. And if you notice, this window comes with an X to close the window out, some controls that are default controls like that we haven't really talked about. We didn't even ask Pygame to produce these controls, but they're here. If I want to resize my window, however, if you notice, my window doesn't resize. It doesn't have those handles that allow me to resize the window because I haven't programmed them in. You can program that stuff into Pygame, and you can also do that with Tkinter as well. And we'll talk about Tkinter again as we move forward. So let's go back. I'm just going to exit this thing, right? So I'm exiting out of our window. I'm going to go back to my presentation here as we move into the next framework, which is going to be the alter framework. So again, with the PowerPoint is going to go through this stuff in more detail. I've just done it in Aptana, so I'm going to kind of skip through this. So we're going to, again, we set the screen size, the window capture. We talked about this. We also, as it says here, we convert to Pygame format, because if we don't convert to Pygame format, it won't display properly. We get an error, right? And that's part of the required methods that you need to use when you actually define your surfaces. When this is background, you can also call it frame, call it whatever you like. So it can be a frame or a sidebar within the main window, okay, the top level window that you're going to be creating. Okay. So here we come into the action part of our loop. So we've displayed our window, but we want to be able to create some action so that the window actually does something, there's some kind of interaction with the user. So let's talk about the action, the acronym for the alter framework. So part of the action is we're going to assign values to key variables. All right. So for example, we might assign a value to a high score variable. We're going to might assign a value to a health variable, like I said before, for a character's avatar. Or we might assign a value to how many enemies there are on the screen starting off, and so on. We also may assign a value for the difficulty level, level 1, level 2, level 3, or easy, medium, or hard. These are all things we can assign before we start the alter framework, or as we enter the action part of our loop. Then we're going to create our loop. We talked about this before. We're going to create our game loop itself. We're going to just kind of define the timing of our loop, how fast this loop runs, right? How many frames per second. And then we're going to listen for events. We're going to create event listeners, right? And again, this is the exact same, whether you go with Pygame, Tkinter, PyQt, any kind of framework you decide to work with, Cocos 2D, whatever it is, you're going to have this kind of a framework that you define. Okay, and then we're going to refresh the display. So every frame, we're going to refresh the display and update these game entities that are going to be on the screen. And here it is. So let's switch back to our Aptana Studio here, and I'm just going to exit out of here. And like I said, exit out of here. Tom, you're awesome on mine here. All right, and we're going to switch back here. So here's the alter framework right here in Aptana. If you notice, we're going to define a clock variable. The clock variable is actually going to assign Pygame.time clock, and the clock module itself is going to start the clock ticking, right? And typically what we're doing is we're instantiating a clock object, which is an object with the time class that we're defining here, which is part of Pygame, by the way. So we don't have to define anything else. So this is part of the stuff that we're going to do. This is one of our key variables, the clock variable, how fast our loop runs. Okay. Isn't that funny? Down here, I've got frame rate set to 60. It should be actually 30 as per our documentation. Let me just save that. You can. This is where you actually set the frame rate right here, right? But as you notice, let's go to the next part. So that was the A part of alter, which is assign key variable. This is where you're going to assign all your variables up here. And then you're going to start off the main loop. So while keep going, because keep going, right? There's another key variable. That's our sentinel variable. We're going to check that to make sure that our game has to continue. Okay. So T for our timer. We're going to set our clock timer, and if I hover over an example now, it's going to show that our timer is set to 30 frames per second. That's what this thing does, right? Okay, and then we're going to listen for some. We're going to do some event handling. In this particular case, the event that we're going to handle is this Pygame.event. The Pygame.quit event. This is the event that we're listening for. We're going to create a for loop. And we're going to create a for each loop. If you remember our previous lessons, where we say we're going to find a new variable called event, right? It's just a placeholder, right? And for every event, every frame, basically we're listening, right? We're gonna listen to this. We're gonna actually invoke the pygame.event.get method to start listening for events, and we're going to load them into the event variable. Right, that's what we're going to do. So this pygame.event.get, it starts off the event listening portion of our code, right? And all the events are going to appear here inside this event variable. And then we're going to check if the event.type, so the type of event, because remember this event type is actually what we're defining here is an object again. So we're saying once we say pygame.event.get, right? If we do that, right, we instantiate this new object called an event object. And then we're going to say depending on the type of event, if it's a pygame.quit event, we're listening for that type of event, then we're going to say, well, we don't want the game to continue. So we're going to say our sentinel variable is going to change to false. Right? So this while loop condition is going to fail, and we're going to quit out of our while loop. And if you notice, again, from a code block perspective, everything under here that's equally tabbed, right, is part of our while loop block, our code block. So that's right in here. So this is where we actually exit the code block if the user hits the quit. But what's the quit? The quit is the X on the window. That's what this thing is, right? So that's what it allows us to do. Okay. Now the R, the refresh display. So here's where we're going to actually refresh the display. We're going to actually do a screen.blit. And when we blit an object, we're actually going to do two things. We're going to refresh the background, right? We're actually going to throw back this on the surface. We're going to blit it, and we're going to blit it starting at these coordinates, which is 0, 0, the top left corner of our screen. Because our coordinate system for Pygame starts 0, 0 on the top left corner of the screen, which is kind of contra to our whole idea. Because typically when we are in math, we think of 0, 0, the coordinates are at the bottom left corner of a screen, right? When we build graphs and charts and so on, right? But in this particular case, our screen resolution starts at the top left corner of our screen. All right, and that's going to be different for different frameworks. For example, in Cocos 2D, if I'm not wrong, it follows math as well, and it goes in the bottom left corner of your screen. There's other frameworks that handle the coordinate system a little differently. And then what we're going to do is we're going to flip the display, right? And what this does is it's going to update the full display on the screen. That's what it's going to do. So we're going to do a couple things. We're going to blit the screen on the background, so redraw the screen, and we're going to refresh the display. That's what this is doing. So as long as we don't quit, we're going to continue to refresh the display and show that blue background. Okay, once we're out of the loop, that's the end of our function. And since that's all we're calling when we use this meta tag inside of our preprocessor command right here, which is if name is equal to main. Once we're done, we're out, and we finished our code. Now, you may have an issue, I'm just going to warn you in advance, with this pygame.quit working from within idle. It might crash your idle if you're working with this. It might actually crash your code. But that's okay. I'm just warning you in advance that this is what this does. But here in Aptana, it doesn't crash this at all. So if I run it again, here it is, I'm running the window, and as I run it, it appears here at this particular location. I haven't told it where to appear. But the surface, see the window here, it comes up with a couple things again, just to go over it. You've got your title bar with hello world, you've got your controls here with an X and so on, and you've got your surface which runs the exact width of the window. You can make the surface different sizes. You can only make the surface cover half of the window. As an example, you can create two different surfaces, one on one side, one on the other. Or you can try to create multiple surfaces. In this particular case, we're only creating one surface. Okay, so I'm going to exit out of here again, and when I do, when I click on this close button, then my pygame.quit event fires that I'm listening for. And if it does, if the event type is equal to pygame.quit, then my keep going variable is going to be false, and I'm going to exit my loop. All right, let's go back to our PowerPoint presentation really quickly. And it's looking like we're close to that. We're going to be taking a break in a second. So when we come back, I'm going to go over these individual steps in more detail. All right. So for now, we're going to pause, and when you notice, I'm going to probably break this video up into a couple of videos, like part 1, part 2, just for the sake of uploading, maybe even part 3 if we go into the third hour. And when we do, I'm going to upload these videos all separately, probably again to YouTube. Okay. So here I'm going to just pause our recording.